Okay, guys. In this video, let me rewind and just apologize. The quality of my voice is even worse than normal. Allergies are hitting me, and I have a terribly scratchy throat, and I'm sure there's going to be times when it sounds like I'm going back through puberty. So every time my voice cracks, take a shot, and you might be drunk by the end of the video. Okay, so what we're going to try to do in this video is something that's difficult for students in the beginning, just because we're not used to thinking about equations and functions in this way. When we want to find the domain of an equation or of a function, we are attempting to find what x's am I simply allowed to use or plug in. Okay? There's a handful of exceptions that I'm not going to focus on. I want to try to keep this video as simple and streamlined as possible. So if we want to focus on the values of x that we're allowed to plug in so that we don't do anything illegal, like dividing by zero. We've talked about in other videos how dividing by zero is just arithmetic that doesn't make sense. Or the other common thing that we have to watch out for is we know that if we end up taking the square root or really any other even root of a negative number, we're going to get imaginary numbers. So for this chapter, we're going to set imaginary numbers aside, and we want to focus on everything staying real. Okay, I don't want to have that imaginary number I popping up. So the two things that I'm just going to be mindful of when I'm looking at a function and trying to decide, what is its domain? What am I allowed to plug in for x? Number one, don't divide by zero. And number two, don't take the square root or any other even root of a negative number. Okay? It's going to come down to those two things. So if I look at a function, until we introduce some other things, or again, with a handful of exceptions, I'm going to look for just these two things. Do I have any variables in the denominator? If so, then I need to worry about dividing by zero. And do I have square roots involved? In which case, I need to worry about taking square roots of negative numbers. So what we're going to do is we're going to look through a handful of examples together. And then at the end of the video, I'm going to give you some additional things to try on your own. And if you got them, great. If you didn't, I'll have an explanation at the end of the video, just in case. Okay, so this probably will end up being a bit of a longer video, but hopefully you find it helpful. So for our first example, let's find the domain of f of x equals 3x squared minus the square root of 10 minus 4x plus 11. Okay? All kinds of things that we could do with this function, but the only direction I'm given is to find the domain. What are the values of x that I'm allowed to plug in so that I don't end up dividing by zero and I don't end up taking the square root of a negative number? Okay? So with that in mind, if I'm not supposed to divide by zero, do I have any division inside this function to worry about? I don't see any division, so I'm not worried about dividing by a potential zero for some particular value of x. But I do have square roots. So I need to make sure that my square root never ends up being a negative number underneath. Okay? Now, this is the hard part for students in many cases. Check out this thing right here. Am I worried about any particular values of x for this part of the function? No. I can take any number, positive, negative, fraction, silly number, whatever it is. If I square it, I'm going to get some real number back. So this guy, this part of the function is no concern of mine, not when it comes to finding the domain. Ditto here for the 11. I'm not really worried about this 11 because there's nothing I can plug in for x that's going to change this 11 from being an 11. And adding 11 is a perfectly fine, good thing to do. So the only problem I have is with this square root, and specifically the part underneath the square root. Okay, that's called the radicand. Fancy word. Name your kids radicand, you'll never forget. So what I can do mathematically to make sure that the number underneath the square root, the 10 minus 4x, is never negative, is I can set that part, 10 minus 4x, and I can set it greater than 0 or equal to 0. Because if it's greater than 0, it's positive, or if it's equal to 0, then it's not negative. Those are the only three kinds of numbers we have in the real numbers. They're either positive, they're negative, or they're 0. So let me use this. By taking the radicand, the 10 minus 4x, setting it greater than or equal to 0, that's going to be, now, and then when I solve for x, that's going to tell me what the values of x are going to be so that the number underneath the square root is always, always, always positive. Or, well, not 0. I'm sorry, not negative. Also, I've been taking a lot of medication for these allergies, and I don't have my full wits about me. Apologies. Hopefully I catch all my verbal mistakes. Okay, so let's focus on this green part. The hard conceptual part is what we just did. You take what's underneath the square root, you set it always greater than or equal to 0, and then you solve for x. So this is a skill that we've already practiced before. So I'm going to isolate my x. I'm just going to turn on my autopilot. I'm going to subtract 10 from both sides. I know I can subtract 10 all day long, and that's not going to change my inequality. It's going to stay greater than or equal to. Left with that negative 4x. 0 minus 10 is negative 10. And then to solve for x, I'm going to divide both sides by that negative 4. But remember, we just divided our inequality by a negative number. So that means I've got to flip greater than or equal to around and rewrite it as less than or equal to. Otherwise, the negative 4's cancel, and I'm left with x on the left, negative 10 divided by negative 4 on the right. I know a negative divided by negative is a positive. Otherwise, 10 over 4 reduces to 5 over 2. And then when I express the domain of a function, we typically express it in interval notation. So recall, if x is allowed to be any value that's less than or equal to 5 over 2, if 5 over 2 is right there, then x can be anything to the left of that. And including, so I'm going to give it a square bracket. So interval notation, final answer. What do I have shaded? I have all the numbers from parentheses, negative infinity, comma, up to 5 halves with a square bracket. And let's box that in blue. And that's my domain for that function, okay? So I just want to go back and emphasize. If I were to pick some rando number, like 0, 0 is included in that shaded space. If I were to evaluate f of 0, forgive me if this is confusing and messy, but I want to stay on this screen and scribble. So I'm going to go in black over here. So if I want to evaluate f of 0, we're claiming 0 is in the domain. So f of 0 would be 3 times 0 squared minus the square root of 10 minus 4 times 0 plus 11. Let me do some arithmetic. Okay, I lost my train of thought. Somebody was walking by my office and was talking to me, so I had to pause the video. I don't know if you could hear her. Anyway, so let me rewind a little bit. I'm going to do some mental math just for space. So I'm going to do all of this in my head. 0 squared is 0. 0 times 3 is 0. So that is 0 minus 4 times 0 is 0. 10 minus 0 is 10, so I have the square root of 10. And because I'm good at math, I know that the square root of 10 doesn't simplify. And then I have that plus 11. And it turns out that the last thing that I can do to simplify this is basically say the 11 plus 0 is still 11. And so I have 11 minus the square root of 10. And I don't even know what that value is. Square root of 10 is going to be slightly bigger than 3 point something or another. So 11 minus 3 point something or another is around 7 point something or another, like 7.9-ish, perhaps. I'm not even going to check on the calculator. You can do that on your own if you want. But 7.9-ish is a real number, which is the point. 0 is in the domain of this function because when I plug in 0 and evaluate it, I end up with a real number. I don't end up with an imaginary number because I didn't take the square root of a negative number. Okay? On the other hand, let me clean up my space. What would happen if I tried to evaluate this function for something that wasn't in the domain? So let me pick on something like 13. What happens if I try to evaluate f of 13? So again, over here, scratch work. F of 13 equals 3 times 13 squared minus the square root of 10 minus 4 times 13 plus 11. And my bad, guys. I thought this was going to work out a little bit nicer, but I goofed, and I know my editing skills are too poor to go back and edit this part out. So we're just going to run with it. A little bit of mental math. 13 squared is 169. 169 times 3. I'm kidding. I'm going to pull out my calculator. 3 times 169 is 507. Minus the square root of 4 times 13 is 52. So 10 minus 52 is negative 42. Plus that 11. And I'm going to put us all out of our misery and just sort of stop there and acknowledge there's no problem with this number and there's no problem with this number. But because we're taking the square root of a negative 42, we know that's going to end up being imaginary. We're going to be able to pull out an I from that. And so therefore, none of this is a real number. This would be a complex number. And so that's the reason why 13 isn't in the domain of this function. It's why it's over here, not in the shaded region. Okay? So let's do another example. Let's say this time we want to find the domain of g of x equals x squared plus 4 divided by x squared minus 2x minus 120. Okay? Quick refresher. The two things that I'm going to worry about for right now are, number 1, don't divide by 0. Number 2, don't take the square root of a negative number. Those are the two bad things. Okay, so with that in mind, I look at my function, and do I have any square roots this time? No square roots present, so I don't have to worry about taking the square root of a negative number. But I do have to worry about dividing by 0 because I've got a big fraction bar, and I've got the variable in the denominator somewhere. So there's the possibility. There's not a guarantee, but there is a possibility that some values of x may give me 0 in this denominator. Okay? So to put it another way, I have a problem when my denominator, x squared, minus, that should be a 2x. I can clean that up really quickly. Not to brag, but minus 2x minus 120 equals 0. So if I recognize that this is when I have a problem, then if I can find the values of x here, then I know that I'll have to throw those guys out because they're the troublemakers. But every other value of x should be good, okay? So next up, we have to recognize, well, what is this? So this is a quadratic equation because I've got x squared. It's set equal to 0. And I did myself a favor, and I came up with a quadratic equation that could be factored because I like factoring. It's my second favorite F word, okay? So what I'm going to do is I'm going to try to find the factors of negative 120 that are going to add up to give me a negative 2. And so what I'm going to encourage you to do is to pause the video, see if you can find those factors like we've done before, and do the factoring by grouping and all that sort of stuff, okay? When you're ready, unpause the video and let's see if we agree. And voila. While we were all paused, this is what I came up with. The magic pair of numbers that I found that multiplied together to get me negative 120, that add up to get me negative 2 were positive 10 and negative 12. So I split up my negative 2x like this, did my factoring by grouping here, pulled out an x, factoring by grouping here, pulled out a negative 12. When I did that, what was left over? X plus 10, they're a match. So that's my GCF. I pull it out front, and what's left over is the x minus the 12. So I've got my factors. It's still equal to 0, but after this, it gets really easy. We just set the individual factors equal to 0. X plus 10 equals 0, or x minus 12 equals 0. Solve for x. For space, I'm going to do it in my head. I know that if x is negative 10 here, I get 0 there. And if x is positive 12 here, I get 0 there. Now, I kind of intentionally did the majority of this work in red because where did all of this start? Why did we just do what we did? I have a problem when this thing equals 0. So what happens when x is negative 10? When I plug it in here, negative 10 squared is positive 100. Negative 2 times negative 10 is positive 20. 100 plus 20 equals minus 120 equals 0. So if I try to evaluate g of negative 10, I end up dividing by 0, and that's a problem. We're not allowed to do that. Same thing happens when we try to evaluate g of 12. We're going to end up dividing by 0. So what does this tell me about the domain? The domain says I only have a problem when x equals negative 10 or when x equals 12. So imagine a number line that has all of, let's pick blue. All the real numbers. What are my key numbers here? What are my critical numbers here? Negative 10 and positive 12. So we've just established that's a problem and that's a problem. But what about the rest of the real numbers? Those guys are golden. So x can be anything that's less than negative 10, negative 11, negative 14, negative 688. X can be anything in between negative 10 and positive 12, negative 1, 0, 5, whatever. And x can be anything greater than 12. None of the rest of those numbers are going to make me divide by 0, and none of them are going to make me take square roots of negative numbers and end up with something imaginary. So in interval notation, how do I show that every number is included except for negative 10 and positive 12? Basically what we just did here with the clever use of parentheses. How do I show that a number is not included in an interval? I do parentheses. There, and there. So final answer, in interval notation, what's my domain? Well, how many intervals do I have up here? I've got 3 intervals in green. I've got this one, and this one. So I've got 3 intervals to write out. My domain is going to be the interval from -infinity to -10, union that with the middle interval that goes from -10 to +12, union that with the interval that goes from +12 until +infinity. And let's box that sucker in black. That's the domain of g of x. Fun stuff, yeah? Okay, let's do one more example before your practice problems. Okay, so the purpose of this example is to make sure we understand what we're doing. A lot of times, students are guilty of, oh, I've seen that thing before. When I see that thing, this is the thing I do. So, what first is the question asking for? Find the domain. What am I allowed to plug in for x? Okay? So what many of you have probably noticed was this function is a quadratic function. You're like, oh, quadratic functions, quadratic formula or factoring or something like that is going to be involved. But I'm here to tell you some good news. The good news is this problem is so easy, it's hard. It's a commonly missed problem because we've lost track of what should we be focusing on. If it's the domain, for right now, for the purposes of this video, what are the only 2 things that we have to worry about? Number 1, don't divide by 0. Number 2, don't take the square root of a negative number. No. So let's look at this function. That is just a beautiful thought bubble. Let's look at this function. Does this function have any division at all? Do I have x's in the denominator? Nope. So am I worried about potential values of x making me divide by 0? Nope. Does this function have any square roots? It doesn't. So am I worried about potential values of x making me take square roots of negative numbers? Nope. So think about this. If this is my number line, did we have to eliminate any values of x from the real number line? No. Any value, to put it in other words, any value that I plug in for x here and here is going to give me something real back. So if I'm not cutting out any numbers, and let's just put some numbers on there for reference sake. I'll do my favorite numbers. -12 and 10, because my birthday is December 10th. Please don't get me presents. You can give me cash. I'll accept cash. No, don't do that. That's a joke. So we didn't cut out any numbers like -12 and 10 like we did on the previous example. I don't know if you guys caught that. So if those guys don't get cut out and nobody else gets cut out, what's my domain? What am I shading here? Oh, that's a terrible arrow. I ended up shading all real numbers, didn't I? So my domain is everything from -infinity to +infinity. Ball game. There's absolutely no work. There was no reason to factor that or to use the quadratic formula or anything else. Again, so easy, students find it difficult. All right? So what I'm going to do is I'm going to give you about 3 more examples for you to try on your own. When you are ready, you can, well, you know what? I'll do them, well, sorry, I know this has got to be painful to listen to. I'll give you 3 examples. Pause the video, try them on your own. push play when you're ready. I'll reveal what the domains are. If your answer matches my answer, then you give yourself a hug. And otherwise, I will quickly go through how I got the domain that I got. Okay? So let me come up with those 3 examples. Okay, so here are 3 functions to try. Find the domain of g of x, f of x, and h of x. Pause the video when you're ready. Unpause, and I'll have the answers for you. Bam. So I hope you got these answers. I probably should have waited a little bit longer before pausing my own video. But, well, whatever. Okay, so as promised, I'll work those 3 examples out rather quickly, just to show you where I got this stuff from. Okay, so to find the domain of g of x, I don't have any square roots, but I do have dividing. Notice the numerator doesn't matter at all when it comes to domain. The only thing that matters is 2x plus 6 cannot equal x. So if I solve 2x plus 6 equals 0, I think I may have said that wrong. The only thing that matters is 2x plus 6 cannot equal 0. So if I solve that equation, subtract the 6, 2x equals negative 3. I skipped ahead. Silly mental math. If it equals negative 6, then divide by 2. Oh, I can do better. Then x equals negative 3. So that's my one and only problem child on this problem. So if x can be anything besides negative 3, that's anything to the left of negative 3, anything to the right of negative 3. So how do I show that negative 3 doesn't get included? With the clever use of parentheses. And so final answer, that's everything from negative infinity to negative 3. And then we pick back up right on the other side of negative 3 until positive infinity. All right. For f of x equals 4/9 x plus 2, I do have an itty-bitty bit of division right here, but I'm not dividing by x. I'm taking the fraction 4/9, 4 divided by 9, and then multiplying that by x. So without that x being in the denominator, I'm not worried about dividing by 0. The only thing I'm dividing by in this problem is 9, which is never equal to 0. There's no square roots, so almost automatically, my domain is going to equal all real numbers. Anything from negative infinity through positive infinity. That's it. So h of x equaling the square root of 12 plus 3x. There's no division, but there is a square root. So once again, I take what's underneath the square root. In this case, the 12 plus 3x. And I set it, well, let's pick on blue. 12 plus 3x. To make sure it's not negative, it can either be greater than 0 or it can equal 0. So then I solve for x, subtract my 12, don't flip. 3x is greater than or equal to negative 12. Divide both sides by positive 3, and because it's positive, I don't flip. And I end up with x is greater than or equal to negative 4. So on my number line, negative 4 is a key. And all the values that are greater than or equal to negative 4 are to the right or on. So square bracket. My domain is square bracket negative 4 until positive infinity. I've got a sneeze coming, so I'm going to end it here. Catch you later, guys.